With the Roman numerals, do we write, when we write them, do we go from right to left or left to right? Like if we were to have a number written in Roman numerals, how would we read it? Right to left or left to right?
I'm not quite sure how to answer that because do we write our numbers from left to right or right to left?
It depends.
Yeah.
We write them from right to left, but we read them left to right.
Well, sometimes you write left to right.
Right, but think about when you're adding it up, you start with the first digit.
When we're adding or multiplying, we generally start on the right. Yeah. So
But when we read it, we read it
they
left to
do
right.
not have a place value as such, but they do have a position. So the bigger numbers start on the left and the smaller numbers are on the right, if that makes sense. Although, if you were to put them, group them by position and put them in a different order, it wouldn't change the value. Do you know what I'm saying?
Yeah, they're-
Like 2 x's are going to be 20 no matter where I put them.
yeah, but if you put, let's
Right.
say 21 is 2x's plus 1, you put x1, x, it's 19, not 20.
Right,
So
right.
it would depend on where you put it.
Did we answer your question?
I think so. It's just because, like, I was looking on one of the quiz questions. It gave us a really big number, like 1,839. And it's like our number, but then they wanted us to convert it to Roman numerals, and it's just I figured it out, but just like how to figure out how to convert the two from a normal number to one.
You can start on the left, just as long as you start theirs on the left, or you can start on the right and work that way, as long as you start on their right. Okay. Anybody else have a question they want to ask about it? Okay. Does anybody have any questions about the feedback that's been put on the board? Are there any of these that you don't agree with that we ought to discuss? I don't have these answers memorized, but if everybody agrees, it's probably a good sign that we've got the correct answers up there. I think in class yesterday we were able to find 1 or 2 that we changed, right? Anybody want to ask about any of those? Okay.
I do.
Yes.
On 28, if the blue rhombus is 1/2, what equals 1?
That was probably the toughest question on the entire thing. Why?
Because there is nothing.
There is not one single pattern block that would fit that, your answer. So you're either going to have to use a fractional part of a pattern block or multiple pattern blocks, depending on which you use, right? Does that make sense? Okay. If that answers your question, why? And what did they put?
They put trapezoid.
Trapezoid is not the right answer there. Because if you put you can put the blue rhombus on a trapezoid and there's still a little a green triangle that isn't there, so it's not the same. So you could put it's, what, 2/3 of a trapezoid, if you're going to use that. Do you want to
So what do you
change?
do? You would change it. What would you do?
Our trapezoid looks something like this, and if you put the rhombus on top of it, the blue rhombus, it only covers 2/3 of it. So we should have 2/3 of a trapezoid if you're going to use trapezoid. But you could also say,
So the trapezoid and the triangle? So 2/3 of the trapezoid and then
So the question reads, if the blue rhombus is a half, oh, if this is a half, what is a whole? It would be what? A whole would be a trapezoid and a triangle, right? Because there's half, there's the other half. Yeah, there we go. Trapezoid and a triangle. Or, if this is a half, then you could say, here's our rhombus right here. That's a half, which means that there's another half, right? So there's the whole, and the whole would be what? 2/3 of the hexagon would be another correct answer you could use. There are several that. You could even say, if the rhombus is a half, the whole would be 1, 2, 3, 4 green equilateral triangles, right? So several answers you could use there. Okay, thank you. Maybe 4. All right. I'd like everyone to convert how about convert that into a decimal, please, and convert this one into a decimal, please. Anybody need more time? Got it? Okay, 3/8. What is it? 0.375. How'd you get it? Rachel?
Times the 3 and the 8 by 125.
You times the by 125.
And then I had 375 over 1,000.
375 over 1,000.
And then we know that
And then you just say 375 thousandths and you close your eyes and write it as a
it's decimal.
decimal. Okay. Anybody do it differently than that? Yeah.
I already, like, from when I was in algebra, we would do that fraction, so I automatically did it 3/8.
You have it memorized. And we're going to talk about that here a little bit later. Should you have some fractions memorized? If so, which ones? Anybody do it a different way than this or have it memorized?
Calculator.
And what did you do with the calculator?
I divided 3 by 8.
Took 3, hit divided by, hit 8, hit enter, and it gave 0.375. Why did you do that?
It looked like a division problem to me, so I used to add a division problem.
Fractions, one of the meaning is divide. So 3 divided by 8. So she did it and got the right decimal. Anybody do it a different way? Yeah.
Division.
So you did it by hand. You did the division, but you did it by hand. Okay. All right. How about this one? What's it?
0.41. And then a bunch of Sixes,
A bunch of sixes.
6 sixes,
6, 6, 6. How far did the sixes go?
6
There were 6 of them,
they rounded up.
and then there was a 7 on the end? What does that mean?
6 continues.
Does everybody know what she's talking about? How many? 6 of them? And then a 7 for your calculator. Some calculators may go more than that and then put a 7. So what's the calculator doing? It's saying this thing goes forever, this 666. And before it goes off the screen, it says, I'm going to check what's out there, and if it's greater than 5 or greater, I'm going to round this up. Okay? So, this is not true. If I put that equals that, that's not a true statement. I could put approximately equal to, and it would be true. But we need to write it like this. Equals 0.416, and then put a bar over the 6. Meaning, the bar indicates what the repetend is, and the repetend is a 6. That is now equal, and that means goes on, which is the same thing. You can write it like this, 4.6. Yeah, this is the best way. Let's not go there. I was going to use the ellipses, dot, 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 but sometimes it's confusing about what goes on and on. Is it the 6 that goes on, or is it the 1/6 that goes on, or what? So this is what we'll do. Okay, again, how did we get this? You can divide with a calculator and get what we've got here. You can divide by hand, in which case you get to here, and all of a sudden you get this case of deja vu, this 6 keep. It's
On the computer, is there a way to put that bar over numbers, like on Word, like for the homework last night? Or should we just do the repetition?
if you have to do this on Word, you need to have equation editor, which then you can do it.
How do you use the equation editor? Try to figure it out.
Yes.
Can we just put like a 6 and then dot, dot, dot?
But then how would that be different than, see, if I go like this, 0.416, what if I put that? Is that the same as this? What's this? This is 0.4161616, and this is what?
416 repeated.
0.416416416, because the repetend is here. Do you see what I'm saying? These are different numbers. So if I just do 0.416 and put dot, dot, dot.
If you put the 6 in front.
You what? I think we probably ought to stick with this, or, yeah. So has everybody learned how to insert their equations? Have you figured it out?
He's showing.
Okay.
Would it be wrong just for the future to put 0.41666 and then a line over another 6, or does it have to be right after the first one?
This is the same as this,
Okay.
which is the same as that, but typically we'd like to write it as compact and as simple as possible. So even though these are both the same as this, this is our better choice. Good question.
I have a question on the 3/8 one. So why did they multiply it by 125? Is that just a rule? Because I've never done it that way. So I was just
We're going to
wondering.
talk about that in just a bit, so hold on.
Okay.
Okay, so to convert fractions to decimals, you divide by hand or by calculator, and then you're aware that you can either get terminating fractions or repeating fractions, right? Every single fraction will either convert to a terminating decimal or a decimal that repeats in a pattern. Okay? Now, I'd like you to turn to your partner, and based upon our homework assignment, I'd like you to share with them how you can look at a fraction. When I look at this, I immediately know that quick that this is going to terminate. When I look at this one, I can tell that fast that this one is going to repeat when I convert it. So tell your partner how you figured that out and why it works, okay?